Okay, we have another kinetics Alex problem, and this is just worded just a little bit differently, but we should be able to tackle these no problem. It says, consider this reaction. We have this compound, which is then going to decompose into these two particular compounds. Okay, and it says at a certain temperature it obeys this rate law. Rate equals, here's our K, okay, times the concentration of the reactant, and that's going to be squared. This tells us that it's a second order kinetics problem. Okay, so if it is second order kinetics, then I write down almost immediately what is the second order kinetics integrated rate law. So when I do that, I do know that, when I kind of have to look that up, but I know that 1 over the concentration of A at a particular time is going to equal K T plus 1 over the concentration of the initial amount of A. That's what that means. Okay, so now let me look at my problem. I do have an initial concentration at 1.15 molar. I have K, which we already know, as I pointed out, is 11.7 inverse molar inverse seconds, and then I have a T. So this is just, again, just really a simple plug and play problem. Okay, so let's just go ahead and do that then. So I have 1 over concentration of A at the given time point is going to equal K. Following this up here is going to equal 11.7 molar inverse times second inverse times the time, which is this, it's just 0.390 seconds, plus 1 over the original concentration, which is 1.15 molar. Okay, so now it's just a matter of doing a little bit of math. So I have 1 over the concentration of A at a given time is going to, when I do this math in here, gives me 4.563 plus 1 over 1.15, which is going to equal 0.8695. I can just simply add those two together so that I have 1 over A at a given time point, which is 0.390 seconds, is going to equal 5.4325. Okay, so that's what I have, and then when that's going to be inverse molar, by the way, that's going to be my units, 1 over molar. So what I can do is I can just invert both of those, and so I can write that the concentration of A at a given time point, and this time point we know is 0.390 seconds, is going to equal 1 over 5.4325 molar. So the concentration of A at 0.390 seconds is going to equal 0.184 molar. It's 0.184. It asks for 2 sig figs, and so my answer that I'm going to put into Alex is going to equal 0.18 molar. So again, just write down the right rate law. Understand that this is second order kinetics. Write down the correct integrated rate law and do the algebra. You should be able to get these done pretty easily.